Today we are going to look at what happens when GPUs get a really good memory upgrade. In late August, NVIDIA dropped a massive surprise, the Rubin CPX, the fastest GPU that could become the go-to for AI servers. But this launch changed things, and when I say things, I mean pretty much everything. Today, we are going to explore Rubin CPX and compare it with its predecessor GPUs. My name is Dr. Abdoli, and this is Tech Talk Time. Rubin CPX is the first product to truly bring together NVIDIA's dominant server GPU with the new HGX infrastructure. So let's talk about how it compares to its predecessor. First, CPX stands for compute and X, as in the unknown quantity. It's the next iteration of their inference GPU, specifically designed for large language model applications. To understand what's new, we need to rewind a bit. Remember how ChatGPT and other text-based AI models have context windows? Basically, how many tokens they can handle before they start forgetting stuff. Tokens are like words or subwords. If the window is small, the AI might not remember early inputs by the time it gets to later inputs. Blackwell, the predecessor, addressed this by massively increasing the context window. The biggest offering from Blackwell is called the NVL72 Ultra, which claims a context window over 32,000 tokens. But here is where Rubin CPX stepped in. It doubled that to over 64,000 tokens. Even better, NVIDIA claimed it can go up to million tokens, which would be enough to handle an entire book or a huge code base without losing track of what's going on. Now, that's a big deal because if you ever use ChatGPT or one of those code generating AIs, you often have to break down your prompt into tiny pieces and feed them to the model one at a time. Not exactly efficient. Here's what I mean. You have a big task like analyzing an entire code base to find bugs or security vulnerabilities. With this small context window, you have to chop the code into small bits, maybe 1,000 lines at a time. Then you have to paste those pieces one after another and hope the AI doesn't lose the thread. By the time it reaches the final piece, it might not remember what the earlier part said. It's not ideal, right? Now imagine doing that with thousands of chunks. With Rubin CPX, you can just feed the entire code base, one file, or even the whole directory. It's a game changer for software developers. And it's not just for coders. Everyone who uses AI for text-heavy tasks will benefit. Content creators, journalists, researchers, business people who sift through tons of reports. All of those folks need to track a lot of detail, and Rubin CPX makes that possible. Of course, for these use cases, having a big memory capacity is essential. That's why NVIDIA's claim that Rubin CPX offers 3 times memory and capacity than Blackwell is a major selling point. Now, let's talk about how they did it. In simple terms, they broke down the task of processing a text prompt into 2 parts. Basically, from architectural point of view, they divide the architecture in 2 parts. One GPU handles understanding the context of the massive input, and the other GPU focuses on generating the output. This way, they can divide and conquer instead of trying to do everything at once. It's like having a specialized team where some people are great at remembering stuff and others are great at coming up with ideas based on that memory. Of course, it's not quite that simple, but there is a lot more to it technically. Additionally, Rubin CPX boasts doubles the throughput and 3 times more memory bandwidth. All of this helps handle extremely long sequence of text efficiently. But it's not just about the GPU itself. NVIDIA also launched a new system called the NVL144 CPX, which houses 144 Rubin CPX GPUs along with 144 standard Rubin GPUs and specialized CPUs. Think of it as a supercharged computer that's designed to handle these long horizon tasks like a chump. When you compare it to the older NVL72 racks that ran on Blackwell, the new CPX system are more than 7 times larger in scales. They offer 8 extra flops of compute, 100 terabyte of fast memory, and 1.7 petabyte per second of bandwidth. That's some serious horsepower. If you want to learn more about the specs and capabilities of these chips, check out our upcoming videos. We go into detail there, and if you want to dive deeper into topics like this, consider subscribing to our channel. Alright, let's move on. So now you might be wondering, how much is this going to cost me? Well, that's a bit of a complicated question. The NVL72 racks, the previous generation, came in around $3.7 to $4 million. But NVIDIA hasn't released official prices for the new CPX system yet. Analysts are estimating they will cost 20 to 50% more. Let me put it into perspective. A standard HGX 800 system, which includes 4 800 GPUs, costs about 100 grand. A Blackwell NVL72 racks hold 72 GPUs and run for around $4 million. On the other hand, the new CPX system packs 144 CPX GPUs and will likely be priced in the range of $4.5 to $5.5, even $10 million. It's expensive gear, no doubt about it, but it's designed for hyperscalers. These are companies like Google, Microsoft, and Amazon who train and run gigantic AI models. So for them, the price is justified. The big question is, what kind of application can benefit from this? Well, think about any task that requires dealing with long sequence of data. The obvious example is extended context in language models. But it goes beyond that. We are talking about workload that spans multiple times the steps like video analysis, financial modeling, or climate simulation. In fact, the possibility is endless. For instance, imagine a world where long horizon chatbots become a reality. These bots would remember past conversation and interaction to provide more personalized and relevant responses. Or picture research assistant that can quickly sift through years of data like legal or medical document and provide accurate summaries. It's not science fiction anymore. It's on the horizon. One area where this technology can shine is industrial setting. Think about factories or power plant where machines generate huge amount of sensor data every day. By using Rubin CPX, companies can analyze all that data at once, spot pattern, and make informed decisions quickly. It's like having a digital twin of a physical asset that can learn from its own history and predict its own future. Of course, these are just a few examples. There are plenty more where long-term memory and context are needed. And with Rubin CPX becoming available, developers can explore these new possibilities and create innovative solutions. It's a tool that will push the boundary of what's possible with AI. So what do you think? Does this update changes the way you think about AI infrastructure? Let us know in the comments below. And thanks for tuning in, and see you in the next video.